Hello friends, welcome you all to the next lecture of the JCE Connect series of online lectures. We are dealing with module 4 and the topic of discussion is moment of inertia. In the previous video, we have gone through the first example, which was an unsymmetrical eye section. The section was unsymmetrical about horizontal axis, but it was symmetrical about the vertical axis. Hence, in that example, we needed to locate the y bar coordinate of the centroid and further find moment of inertia about the reference axis I11, then obtain the moment of inertia about the horizontal centroidal axis Ix. And as the figure was symmetrical about the vertical axis, we could directly get the value of Iy, that is I bar y, which is the moment of inertia about the y centroidal axis, as summation of Igy. Then we had one homework example. Hope you have solved that examples. Let's go to the further problems. So we will deal with example 3. Now what I am trying to do in every example is pick an example which has something unique or some different things given, so that we will be able to cover up maximum type of examples as we do in the regular classrooms. It might be a bit difficult to catch up, but I hope all of you will practice and get back with the doubts if you have any. So let's start with the third example. Determine the moment of inertia of the section for the figure shown about its centroidal axis. Centroidal axis means xx and yy. Calculate the least radius of gyration for the section as well. Okay. So here we have to find I bar x and I bar y, which are the moment of inertias of the entire figure about the centroidal axis, and going further beyond, we need to also calculate the radius of gyration. So radius of gyration we have discussed in our initial chapter, okay, initial videos we have discussed. Again, once again, when we come to this problem, we will have to apply those formulas. So now the same example we have already covered in CG, okay, same example we have solved for obtaining the centroid. How is this figure? It is unsymmetrical about both the axes, that is centroidal x axis also, centroidal y axis also, it is unsymmetrical. So when you look at the given example and the given figure, we will find the axis 1 1 and 2 2, okay, which are marked, which will be our reference axis. If those are not marked, you have to mark them and take as the reference. Okay, you have to mark those axes and take as the reference for solving. So now what happens with this type of examples is you need to make the entire table. You cannot skip x bar or y bar as it is unsymmetrical. So table becomes quite big and number of calculations involved also are high. So what I prefer from my experience is, if you get an object which is symmetrical about one axis, unsymmetrical about another, go for moment of inertia examples. But if you get figures like this which are not symmetrical about both the axes, that means you have to go for all the calculations. It becomes a bit lengthy task. I am not saying it is difficult, but it becomes lengthy. Now at that time, if you are perfect with centroid, prefer centroid option in the question paper. Okay. So when you can prefer moment of inertia is when the figures are a bit simple, that is symmetrical about one axis. Moment of inertia problems become very easy. Or if the example is asked directly with respect to a given axis, we did not apply parallaxis theorem and all, those examples which we will solve further, okay, those all are quite easy. But when you have to find both Ix and Iy, okay, both Ix and Iy, and also obtain x bar and y bar, the example becomes a bit more lengthy. So let's start with the example. I think you are familiar with the figure. We have a C type of shaped figure with two horizontal rectangles and one vertical rectangle. We have named them as 1, 2 and 3. 1, 1 and 2, 2 are our reference axis. Okay, 1, 1 and 2, 2 are our given reference axis. 1, 1 is the horizontal reference, 2, 2 is the vertical reference. So let's go ahead with the figure and the table. Now for your comfort, I have tried to fit in the figure in this screen also. So let's go ahead with the discussion of calculations. So first component is a rectangle. Area will be 120 into 10. X, okay, x is what? The vertical distance from your reference axis, which is at the bottom. Okay, so here we can take with reference to your vertical axis, which is at the left side. So x value for this element will be 30 by 2, which is equal to, that should be 120 by 2, which is equal to 60. Please excuse me, this is 120 by 2, which is equal to 60. Then y value will be 120 minus 10 by 2, or we can go ahead like 10 by 2 plus the vertical height plus the 10. But as the vertical element height is not given, you should be careful. That is, the second element height will be 120 minus 10 that is 100. So look at the example, 120 is mentioned directly. It is not the height of two component, because two component, if you want the height, you have to minus the bottom 10 and top 10, okay, which we will do in the next step. So then find ax, find ay, find ax square and find ay square. As the table becomes too long, I have split the table. Next part you will get in the next screen. Then for the second element, width is 12 and your height is 100. Why we are taking the height 100? See, 120 is from top to bottom, but our element 2 we are not taking from top to bottom. Okay, we have to divide that element properly, and top minus 10 is gone, bottom minus 10 is gone. So height of the second element is 100. So area will be 12 by 100. Then the x value, that is the horizontal distances, width by 2, that is 12 by 2. Similarly obtain y bar. Now here y bar, how you can calculate is 100 by 2 plus 10 is one way, because if you take the element height as 100, y bar will be 100 by 2 plus 10, or you can take the total height also and by 2, then that plus 10 element will not come. Better, instead of 120 by 2, you can also go ahead with what is the height of the element, second element, 100. Now I have put this purposefully because you got to think at these points. If I tell everything as it is, it becomes damn easy. So when you are locating y2, how you can do is, you locate y2 as 100 by 2, 100 by 2, which gives you 50, plus 10 is 60. Answer is same, need not worry. Then find ax, obtain ay, next find ax square, next find ay square. Okay, so things will go smoothly up to here, no issues. Then come for the third element, the area is 180 by 10, x3 will be 180 by 2, y3 will be 10 by 2. Then next ax, ay, ax square, ay square. So we will get this table, first part of the table. Summation area calculated, summation ax, summation ay, summation ax square, summation ay square. So remember, up to ax, ay you have already done this example. Okay, need not worry about it. Next comes the remaining part of the table. As it doesn't fit properly in the screen, I have divided the table. You did not divide it. You can make one continuous table. Okay, make one continuous table and solve. You can use the page horizontally, that is in the landscape mode also. So now next part is, we'll find igx and igy. What is the formula for Igx for a rectangle? BD cube by 12. Igy dB cube by 12. Okay, apply properly. What cube you have to take? The side which is perpendicular to the axis under consideration, uska cube lena hai. Okay, so here we are talking about Igx. Okay, x means horizontal axis. So vertical element cube we have to take in finding the Igx value for the first element. Igx1 will be 120 into 10 raised to 3 divided by 12. Okay, that is BD cube by 12. Then Igy1 will be DB cube by 12. Then for the second element, BD cube by 12. So B is 12 and D is 100. So please don't take 120 here. Mark this. Here is a possibility where you can make a mistake by taking 120. Second element is 12 by 100 only. So BD cube by 12. Again DB cube by 12. Similarly, find the Igx and Igy values for the third element. Then get the summation Igx, summation Igy. This completes our entire table. Okay. So as here both the axes were, the element was unsymmetrical about both the axes, we required to find all the elements of the table, which becomes very big. So our solution part. Now once this table is ready, it's just application of formulas. X bar will be equal to summation Ax upon A, Y bar will be summation Ay upon A. Then as per our procedure, I11 is equal to summation Igx plus summation Ay square. Get the value of moment of inertia about 1 axis, use parallel axis theorem and get the moment of inertia about x axis, that is I bar x equal to I11 minus A y bar square. So what is the statement of parallel axis theorem? Actually I11 will be equal to I bar x plus A y bar square. So just I am interchanging the terms, taking left to right, right to left and updating the equation for I bar x equal to I11 minus A y bar square. Now this y bar is the centroid for the entire figure which we have calculated above. Okay, that is 52.143. So using all the values, get the obtain of I bar, get the moment of inertia about centroidal x axis, that is I bar x. Now same procedure we have to repeat in other direction. That is I22 is equal to summation Igy plus summation Ax square. We have to interchange the terms properly. So solving, we get the moment of inertia about the y-axis. So here these both are your required answer. This is 9.841 into 10 raised to 6, which is moment of inertia about x centroidal axis, and 11.704, okay, below here 11.704, which is the moment of inertia about 11.407, sorry, into 10 raised to 6, which is the moment of inertia about y-axis. Okay, so those both are your answers of moment of inertia about x and y centroidal axis. Problem doesn't end here, because what is asked is we have to find radius of gyration also. So if you miss this, your 3 marks will go. So what is the formula for radius of gyration? I think in the internals also you had this. Kx is equal to square root of I bar x upon A, where I bar x we found out just, and A is the total area. Okay, it is not the independent area. A means total area. So we get Kx as 48.406. Similarly, we calculate the value of Ky using the formula square root of I bar y, that is moment of inertia upon about centroidal y-axis, divided by total area square root of the answer. We get Ky as 52.1126. Then what is asked? Least radius of gyration. Okay, so least radius of gyration among the above two is Kx. Therefore least radius of gyration is 48.406. Now this itself will be your 3 marks. So if this example comes for 20 marks, it will be distributed. Okay, tabular column, x bar y bar calculation, I11, Ix, I22, Iy, then radius of gyration. Okay, so this was a lengthy example. Hope you all will practice this nicely so that the further things we can move ahead. Please don't get demoralized if you don't understand the starting parts and keep the video like that only, because exams will be conducted in the future and this topic will be very very much important, as these examples are common for your theory examination. Hope you all will cope up. Thank you.